he's talking about, it's pretty cool because he's a local. He tells me he's got interest in like a wide range of things, stretching from NLP to computer vision. And he's going to give us a bit of a kind of a more practical look on a real low resource language, how to build language models.
Hi, thank you so much. This is awesome. I'm really happy to have met all of you. So, I'm interested in low resource languages, and my exploration of this led me to study at a school, online school called Fast AI. And from there, I just ended up doing a lot of practice on online data sets. So one of my first explorations was whether one can build a language model, and then what one can do with that from then on. So language models are tools, right? They're general tools. They can be used by pretty much any downstream task. So the idea is to train an unsupervised next sequence or next token prediction challenge. And the idea is to train a model that can accurately predict the next token from a group of tokens that have been provided by a previous data set. So the idea here is we build this and you use it for something else later. So you want to maintain a fixed set of tokens, you want to maintain a fixed set of terms, and then use that for a second set of problems. So an example of this is GPT-2, BART, and ULM-FIT, which Sebastian has first published. So the problem here is being able to identify each distinct token in such a way that it actually improves the progress of the whole model. We realized during the project that things like tokenizers that take count only the word just ignore so much information, because the language like Swahili, you concatenate very many subword tokens or subword units in order to make meaning. So the idea here is to learn how to extract the correct tokens or some version of correct tokens by basically cutting up a word into multiple units. So if you have a word that has 10 characters, split it up into random sections which have 2 or 3 or 4 different kinds of units, and then predict which ones are going to be represented in a downstream task. So this is called sentence piece tokenization, and it's basically one of the best methods for doing this kind of thing. One other method I found out about through the posters yesterday is by Jade's work using byte pair encoding, and it turns out to be the same kind of thing. So yeah, that's actually a cool method. And the model itself is it's an AWD LSTM. So this kind of model is just run-of-the-mill LSTM, except you have a bunch of different kinds of dropouts that are added into intermediate layers. The good thing about this is that it introduces its own version of regularization for LSTM, and that makes it very efficient. So this is, I don't know whether you can see this. This is an example of the output. So this, one of the best ways to evaluate these kinds of things is to just look at the output and see whether it actually outputs things that make sense. Although it's limited in terms of the number of sentences it can output at the very end, mostly because of the size of the data set. So I guess if you can read Swahili, you can see that it actually makes some sense, but it makes a lot of weird mistakes with the loops. It's mostly because of the kinds of terms that are provided by the model, and then the predictions that are made. This is I think it's on GitHub right now, so you'll be able to look at it later. This is a link. I think you'll be able to see it and then play around with it, and we can talk about this. So, as you can see here, the terms that are being predicted from the origin sentence, which is this first token here, this first list, and this is the model output. The terms that are being provided here are limited mostly because of the size of the data set, and we need to figure out how to improve and how to increase the size of the data sets that we have available to us. And this is where, I guess, the next steps of this project come in. We need to build communities that can contribute this kind of data, And it's not just about free text data. So something that I think would be interesting is to build sentiment analysis tools in a lot of these other languages, or text classification or something, which means we need to be able to find a place online which contains this kind of descriptions. So maybe it's comments, or maybe it's explanations of things, reviews, and basically either label them or find the sources where things have been labeled. So one of the things that I have found to be interesting for language modeling on its own is the Tanzania Hansard. It's much, much bigger than Wikipedia. I think it's maybe 3 or 4 times. I'm in the middle of building a language model for this, except that it's quite inaccurate, mostly because of transcription errors from OCR. So the data acquisition method was, got PDFs, I used OCR to extract the text and then trained a language model on that. Still has weird problems because of transcription errors from OCR. And then the next step is crowdsourcing, which is where we have this site. So we have basically a collection of sentences that have been published since around 2015 describing images. So there's a challenge called the Coco Captioning Challenge in 2015. You get about 950,000 English sentences describing maybe 350,000 images. So the idea is to take these and basically create projects, language projects to translate pretty much all of those. And the idea is to find and build communities. They can be online communities, they can be local communities. We can include libraries, because libraries can have translation services. So we could figure out ways to integrate a project like this deep into the communities so that people can actually contribute and build their own community resource. And the target here is, because MS Coco challenge is a captioning challenge, we get 2 kinds of data sets. Right? You get captioning data for image to sentence, and you get sentence to sentence, because each of these languages will have its own set of sentences pointing to the same image IDs, or pointing to the same IDs, which means this is a cross-translation data set, right, in essence. So even if people contribute, thinking only just sentences for translation, someone will be able to build a captioning model from that. And because of techniques like the general language modeling, which means we can be able to do transfer learning from there. So from all of the language sources that we have available to us, all of Wikipedia or books or the Bibles, they can be used as the source for language modeling, and then people can use transfer learning on these other tasks. So the plan is to basically make everything open access on a Creative Commons license. This is a screenshot from the website. And yeah, so if the whole goal of this is to basically make a resource for students and researchers, right? So if someone wants to build, I don't know, someone is in school and all they have access to is NLTK, there's no chance that they'll get an African language to practice with. So the plan is to have one of these as the first source that people can actually try and use. So more work from projects I'm working on that are basically not even close to finishing. It's to align embedding spaces from different data sources. So part of my background is in health informatics, and one of the biggest projects I worked on is a database called SNOMED-CT. It stands for Systematized Nomenclature for Medicine. So this is a very strongly formalized set of descriptions for pretty much anything that goes on in healthcare. So descriptions of diseases, body parts, roles in hospitals, drugs. And what this gives us is a very, very formalized way of describing things. And the thing about this database is that it's also hierarchically structured. So the database is formally text, but it's also structured in sort of like a directed graph. So the problem to solve here is whether we can integrate those two into the same embedding space. So we have word vectors from a project called BioCentVec, which is built from sentences, basically published records and clinical notes. So things like papers in PubMed and NCBI. So using word vectors from those sources, and then combining graph embeddings from the SNOMED-CT graph structure itself, and figuring out ways to combine those two into the same space, such that when someone maybe search as a term on a text field, they can actually get things that are hierarchically structured and also semantically similar. So this can be used in AI to build text search engines. It can also be used for image search engines, because there are methods like devise which let people get images, go from image to image, from image to sentence, and from sentence to image, and in a very, very, I guess, similar way, like semantics similar way. So I think this is I have one reference here because of the ULM fit. There are more. I think I'll update this set of slides with every other thing I find based on the questions that you ask. So I think we have time for several questions. So if you can ask, please. Okay.
Well, then we'll be about enough time. What was the name? What was the URL for the platform? Coco Hub. I was trying to Google it. Coco Hub.cc. Is that something you built?
Yes.
Is it open source?
Yes.
So we can contribute to the platform as well?
Yes.
So if we had like a bunch of features, we could have a hackathon for the platform, and then do some language hackathons on top of that, and then do some model hackathons on top of that, and basically we're going to do, yeah, cool. Very exciting thing, we needed it.
Cool, yeah, thank you.
More questions?
So let me add some context to the answer. Okay, so this is built from our system called Pybosa, which is an open source crowdsourcing system. Everything about this is open source already. The only thing that I've added as an extra project is being able to mix and match languages. Right? So that's not built yet because the translations are not anywhere close to finish. But the idea is to basically build an extra part of the website which lets people select language A and language B and download a gigantic JSON field that just lets them translate everything that they want to do. So yeah, it's covered.
Just to make panic, it's down.
It's not down. It's HTTPS. I haven't added a redirect. I haven't added a redirect to Nginx, so it always fails from there. So just add HTTPS.